All waves have a few fundamental properties we can measure and refer to, and these are easiest to picture with a transverse water wave, like this one I'm going to draw here. I'll start with a horizontal line which represents the equilibrium position. This is what the surface of the water would look like if there is no wave. If a wave comes along, some of the water is displaced upwards and some is displaced downwards. So we get peaks and troughs. The distance the water is displaced downwards or upwards is called the amplitude of the wave. The amplitude is the maximum displacement of the water from the equilibrium position. So be careful, it's not the distance from the top to the bottom. And the last label to put on here is the wavelength. I usually draw it from peak to peak, but technically it is the distance from a position on one wave to the identical position on an adjacent wave. So peak to peak is fine. Take care with your drawing though, because you need a bit of precision here. I like to draw a little dash to show that I know I'm drawing a full wavelength, and then make sure the arrows reach the dashes. So those are the main measurements, but we also have a few other properties we can talk about. First up is a time period, which is the time taken for one complete oscillation when we talk about a pendulum, and that definition works fine here as well. Another way to describe it is the time taken for one complete wave to pass a point. Since period is a time, the units will be seconds. Next is frequency, which is the number of waves to pass a point each second. So it is the number of waves divided by time. If we say there is one wave, then that time is going to be the period, t. And that gives the equation that F equals 1 over t mathematically, which is a really handy formula to remember. Lastly, let's look at wave velocity. Like any velocity, it is simply distance over time. But we have another clever bit of maths we can do here. If we say that the distance is equal to one wavelength, that means the time taken is equal to the period. So, velocity equals wavelength over period. And since 1 over period is the frequency, we get this neat equation, v equals f lambda, velocity equals frequency times wavelength.